Welcome to you all. We will continue with module 2, basic characteristics of yarn. In the last class, we established the important characteristics of yarn and we have solved one numerical problem. Now, we would like to solve a few more numerical problems on module 2. So, numerical problem number 2 is in front of you. A ring spun yarn of 30 tex count is prepared from cotton fibers of 3 decitex fineness. So, what information is given to you? Capital T is given 30 tex, right, and also fiber fineness small t is also given to you 3 decitex tex. Estimate the number of fibers present in the cross section of the yarn. So, you need to find out n. What is given more? Assume k n, coefficient k n is 0.95. So, this is basically the problem. You need to find out n. These 3 values are given, right. So, how will you find out this? We know n is equal to k n times capital T by small t, we have already derived. So, now k n is given 0.95 and what is capital T? 30 tex, small t 0.3. So, what will be the value? 95. So, this is the correct answer 95. To give you a small note, if you calculate, many people do, n is equal to 100, since you know n is capital T by small t, which will be wrong, because this formula is valid for parallel fiber assembly, not for yarn, because yarn is a twisted fibrous assembly. For yarn you have to multiply k n, k n has a value not equal to 1, 0.95. This we have already spoken, all right. Okay. So, then we proceed to numerical problem 3. Calculate the diameter of a cotton yarn of 50 tex count and 0.40 packing density. So, what is given? Capital T is 50 tex, mu is 0.4. Consider that the diameter of the yarn is directly proportional to the square root of the count, that means Cochrane's formula we have to use. Show diameter of the yarn in millimeter is directly proportional to square root in tex. This is given, that means d millimeter k into root t, t is in text, t is in text. So, you need to basically find out k. So, k in this unit millimeter, text to the power 0.5 d, let us rewrite it by root t text, right. So, what is d? D is not given, d you need to calculate, t is given 50, okay, no problem. Let us calculate d. Is not it? So, for capital T 50 divided by pi into mu 0.4 into density of cotton fiber, we can take 1520 kg per meter cube. So, what will be this value? If you calculate, you will get this value as 0.3237. This value if we substitute here, square root of 50 will give you a value 0.0458. So, these all numbers are practical numbers. That means, these constants of proportionality, the coefficient of yarn diameter for this yarn is this value, right. Okay. So, now we will proceed to the last problem, numerical problem 4. Consider in a yarn that a set of circular fibers are arranged according to the tightest hexagonal packing arrangement in different layers such that the number of fibers in the first layer is 1. The number of fibers in the second layer is 6 and so on. Find out the total number of fibers that the structure has if it consists of 9 layers. So, it is a problem on hexagonal packing arrangement, tightest structure. You can find out, if you study the structure a little more, you can find out that number of fibers in a layer is equal to one. You can derive this formula. Number of fibers in a layer is equal to 6 into layer number minus 1, except when layer number is greater than equal to 2. So, number of fibers in a layer is equal to 6 times layer number minus 1. This formula is true when layer number is greater than equal to 2. So, that means for the first layer it is not true, valid. For second layer onwards, this formula is valid. you can find it out, you can derive it. Now, so number of fibers in second layer is equal to 6 into 2 minus 1, that is equal to 6. Already given number of fibers in the second layer is 6. Similarly, number of fibers in third layer, 6 into 3 minus 1, that is 12. Number of fibers in fourth layer, 6 into 4 minus 1, 18, and so on. So, what will be total number of fibers? Total number of fibers will be, first layer it is 1, second layer it is 6, third layer 12, fourth layer 18, fifth layer 24, sixth layer 30, seventh layer 36, eighth layer 42, ninth layer 48, so till ninth layer. Show what will be the value? That means, total number of fibers of this structure, if it has 9 layers, this will be the distribution of number of fibers in each layer. The total number will be 217. So, this is the answer to this problem number 4. So, this was our last numerical problem on module 2. So, we have completed module 2. We will now proceed to module 3. Thank you. Thank you for your attention.